Alright, hello everybody. Today we're going to look at evaluating algebraic expressions. So, um, let's start by looking at an example. We have m plus parentheses n minus 1 quantity squared. Now, this is if we want to evaluate this expression if m is equal to 3 and if n is equal to negative 4. So, we have our variables right here. Our first variable is m, and our second variable is n. Now our expression, we're asked to combine these quantities together, and we are given numbers for each variable. So all we want to do now is, in place of an m, we're going to substitute in 3. And then in place of an n, we're going to plug in negative 4. And we're just going to evaluate this now. So we must apply order of operations. So remember that as PEM does. So just to remind you, PEMDAS, there is a saying that is associated with PEMDAS. It's please excuse my dear Aunt Sally, where P represents parentheses, E represents exponents, M represents multiplication, D represents division, A represents addition, and then S represents subtraction. Now, multiplication and division go hand in hand. So if we're dealing with that in an expression and we see both of them, we begin from whichever one appears in the left first. And the same applies to addition and subtraction. So if we see that we're dealing with both addition and subtraction in an algebraic expression, or just when we're asked to evaluate something, we will start from the left side and then work our way to the right side. So our first thing that we must work with is our parentheses. So we work inside our parentheses. We have negative 4 minus 1. So we must evaluate, we must subtract that. Negative 4 minus 1, that gives us a negative 5. And then we have negative 5 squared. Now we must apply, the next thing in our PEMDAS is exponents. So we're going to evaluate the exponents. So we have 3 plus negative 5 squared. Now, recall that when evaluating exponents, it's what essentially is telling us is we're multiplying the number, the base, which is in our case negative 5, by itself, however many times the exponent is, by the power of the exponent. So this tells us that we're multiplying negative 5 by itself twice. So now we have negative 5 times negative 5. This ends up giving us a positive. Recall that we're dealing with a negative times a negative, that gives us a positive value. And we have 5 times 5, that gives us 25. Just dropping down to 3, we now want to combine, we want to add 3 and 25, and we end up getting 28. So evaluating this algebraic expression where n is equal to 3 and n is equal to negative 4, following order of operations, we end up getting the result 28.